Most of the information in this live stream was sourced from Wikipedia under an Attribution Share Alike 3.0 unported license. Additional information is sourced from 15-day celebration of Chinese New Year, Chinese customs, nationsonline.org. Text-to-speech processing was done via the Blaster Online software package. Tonight is very significant in the Chinese calendar. Chinese New Year starts with the new moon on the first day of the first lunar month and ends on the full moon 15 days later, which is today, 26th of February 2021. The first day of the new year is known as Yuan Dan, New Year's Day, First Day, or Duan Ri. During the 15-day period, New Year visits will be made to family and friends. The 15th day marks the first full moon after the Spring Festival and of the New Year, also known as first night of the full moon. The day is well known as Lantern Festival Day. It is customary on this day to eat special sweet dumplings called yuangshao resembling the shape of the full moon. These round balls are made of glutinous rice flour stuffed with sugar fillings, symbolizing reunion. The moon is Earth's only proper natural satellite. At 1/4 the diameter of Earth, it is the largest natural satellite in the solar system relative to the size of its planet, and the 5th largest satellite in the solar system overall. Orbiting Earth at an average lunar distance of 384,400 kilometers, or about 30 times Earth's diameter, its gravitational influence is the main driver of Earth's tides and slightly lengthens Earth's day. The moon is classified as a planetary mass object and a differentiated rocky body, and lacks any significant atmosphere, hydrosphere, or magnetic field. Its surface gravity is about 1/6 of Earth's. The moon's orbit around Earth has a sidereal period of 27.3 days, and a synodic period of 29.5 days. The synodic period drives its lunar phases, which form the basis for the months of a lunar calendar. The moon is tidally locked to Earth, which means that the length of a full rotation of the moon on its own axis, a lunar day, is the same as the synodic period, resulting in its same side always facing Earth. That said, 59% of the total lunar surface can be seen from Earth through shifts in perspective, its libration. The near side of the moon is marked by dark volcanic maria or seas, which fill the spaces between bright ancient crustal highlands and prominent impact craters. The lunar surface is relatively non-reflective, with a reflectance just slightly brighter than that of worn asphalt. However, because it reflects direct sunlight, the moon is the brightest celestial object in Earth's sky after the sun. The moon's apparent size is nearly the same as that of the sun, allowing it to cover the sun almost completely during a total solar eclipse. The first man-made object to reach the moon was the Soviet Union's Luna 2 uncrewed spacecraft in 1959. This was followed by the first successful soft landing by Luna 9 in 1966. The only human lunar missions to date have been those of the United States NASA Apollo program, which conducted the first manned lunar orbiting mission with Apollo 8 in 1968. Beginning with Apollo 11, 6 human landings took place between 1969 and 1972. These and later uncrewed missions returned lunar rocks which have been used to develop a detailed geological understanding of the moon's origins, internal structure, and subsequent history. The most widely accepted origin explanation posits that the moon formed about 4.51 billion years ago, not long after Earth, out of the debris from a giant impact between the planet and a hypothetical Mars-sized body called Theia. The impact blasted material into Earth's orbit and then the material accreted and formed the moon. Giant impacts are thought to have been common in the early solar system. Computer simulations of giant impacts have produced results that are consistent with the mass of the lunar core and the angular momentum of the Earth-Moon system. These simulations also show that most of the moon derived from the impactor, rather than the proto-Earth. However, more recent simulations suggest a larger fraction of the moon derived from the proto-Earth. Other bodies of the inner solar system such as Mars and Vesta have, according to meteorites from them, very different oxygen and tungsten isotopic compositions compared to Earth. However, Earth and the Moon have nearly identical isotopic compositions. The isotopic equalization of the Earth-Moon system might be explained by the post-impact mixing of the vaporized material that formed the two, although this is debated. In 2001, A team at the Carnegie Institute of Washington reported the most precise measurement of the isotopic signatures of lunar rocks. The rocks from the Apollo program had the same isotopic signature as rocks from Earth, differing from almost all other bodies in the solar system. This observation was unexpected, because most of the material that formed the Moon was thought to come from Theia, and it was announced in 2007 that there was less than a 1% chance that Theia and Earth had identical isotopic signatures. The topography of the Moon has been measured with laser altimetry and stereo image analysis. Its most visible topographic feature is the giant far-side South Pole Aitken Basin, some 2,240 kilometers in diameter, the largest crater on the Moon and the second largest confirmed impact crater in the Solar System. At 13 kilometers deep, its floor is the lowest point on the surface of the Moon. The highest elevations of the surface are located directly to the northeast, and it has been suggested might have been thickened by the oblique formation impact of the South Pole Aitken Basin. Other large impact basins such as Imbrium, Serenitatis, Crisium, Smythii, and Orientale also possess regionally low elevations and elevated rims. The far side of the lunar surface is on average about 1.9 kilometers higher than that of the near side. The discovery of fault-scarp cliffs by the Lunar Reconnaissance Orbiter suggests that the Moon has shrunk within the past billion years, by about 90 meters. Similar shrinkage features exist on Mercury. A recent study of over 12,000 images from the orbiter has observed that Mare Frigoris near the North Pole, a vast basin assumed to be geologically dead, has been cracking and shifting. Since the Moon doesn't have tectonic plates, its tectonic activity is slow and cracks develop as it loses heat over the years. One of the major geologic processes that has affected the Moon's surface is impact cratering, with craters formed when asteroids and comets collide with the lunar surface. There are estimated to be roughly 300,000 craters wider than 1 kilometer on the Moon's near side alone. The lunar geologic timescale is based on the most prominent impact events, including nectar. Counting the number of craters per unit area can be used to estimate the age of the surface. The radiometric ages of impact melted rocks collected during the Apollo missions cluster between 3.8 and 4.1 billion years old. This has been used to propose a late heavy bombardment of impacts. The Moon is rotating around its own axis. This rotation is due to tidal locking synchronous to its orbital period around Earth. The rotation period depends on the frame of reference. There are sidereal rotation periods, or sidereal day, in relation to the stars, and synodic rotation periods, or synodic day, in relation to the Sun. A lunar day is a synodic day. Because of the tidal locked rotation, the sidereal and synodic rotation periods correspond to the sidereal, 27.3 Earth days, and synodic, 29.5 Earth days, orbital periods. The Moon makes a complete orbit with respect to the fixed stars about once every 27.3 days. However, because Earth is moving in its orbit around the Sun at the same time, it takes slightly longer for the Moon to show the same phase to Earth, which is about 29.5 days. Unlike most satellites of other planets, the Moon orbits closer to the ecliptic plane than to the planet's equatorial plane. The Moon's orbit is subtly perturbed by the Sun and Earth in many small, complex and interacting ways. For example, the plane of the Moon's orbit gradually rotates once every 18.61 years, which affects other aspects of lunar motion. These follow-on effects are mathematically described by Cassini's laws. The Moon is an exceptionally large natural satellite relative to Earth. Its diameter is more than a quarter and its mass is 1/81st of Earth's. It is the largest moon in the solar system relative to the size of its planet. The Earth revolves around the Earth-Moon barycenter once a sidereal month, with 1/81st the speed of the Moon, or about 12.5 meters per second. This motion is superimposed on the much larger revolution of the Earth around the Sun at a speed of about 30 kilometers per second. The distance between the Moon and Earth varies from around 356,400 kilometers to 406,700 kilometers at perigee, closest, and apogee, farthest, respectively. On November 14, 2016, the Moon was closer to Earth when at full phase than it has been since 1948, 14% closer than its farthest position in apogee. There has been historical controversy over whether features on the Moon's surface change over time. Today, many of these claims are thought to be illusory, resulting from observation under different lighting conditions, poor astronomical